So a little bit of exponential theory here. If we were to draw the normal e, we would think about a couple things. We would say, first of all, e to the x, if x is 0, then anything to the 0 power is 1. So I'd put a dot at 0. I would know that over here, when x was really negative, I can't force it to be negative. The whole thing can't be negative, but if the exponent is negative, I can be really, really small. And then I'm going to take off. At some point, I'm going to take off. So really, really small, but I can't make it be negative. Then it's going to cross through... Oh, that's not very good. It's going to cross through 1 and then take off. Okay. So that's what we would expect. And when we mess with the x, which is what we're doing here, if you see this, we're messing with the x, we're just going to shift it. And in a way that is always a little bit surprising, I suppose, it's always over here. So instead of going through 1 where we had gone through, now we're going to go through 1 5 over. Instead of at 0, we're going to go through that at 5. But everything else is the same. Oh, wait a minute. No, it's not. It says plus 2. So hang on. Here's 3. Here, let's say that's 3. So let me move my dot. Forgot about the plus 2. So it's going through not at 1 like it normally does, but now, normally it's at 1. Now it's at 3. Okay, so it comes along here. Oh, that's the other thing. Now we have an asymptote at 2. So we can never make it go less than 2, but we can have it be really, really close. So really, really, really close to 2, but never quite. And then it goes through 1, so to speak, even though it's 3 now. And then it takes off like a rocket. Okay, so that's what we would expect from our graph. Shifts over 5. The whole thing is lifted up 2. And that's it. And I'll include the nice graph in the next one. By the way, if you're concerned about the bell work, this is the confirmation that we did it right. Graphically, you can take a look at that if you feel like it. I put all 3 graphs on the same graph, on the same coordinates. And then hopefully our internet doesn't do this. This was a real thing. He says this is not an exaggeration. Go away for a while, come back, see what it said. So